What's up, class? It's Mr. Wicklehouse again. Put my picture on here for you. It's me with some shades on, looking pretty good. So today we are going to learn to graph sine and cosine functions. The other trig functions also have graphs, but for right now we're not going to worry about that too much. So let's get started. So this is what sine and cosine look like on a graph, just on an XY plane. You can see that sine starts at the origin and it's just a wave. The curve just looks like a wave and it just repeats itself over and over and over again over something called a period of 2 pi. So 2 pi, or a period, is just the length that the curve goes before it starts repeating itself again. Cosine is very similar to sine, except it starts up here at 1 instead of starting at the origin like sine, and it comes down, but it still has that same wave pattern, and it just repeats itself over and over and over again forever. And it also starts at 0 and goes to 2 pi. Okay. So that's what the parent functions look like, and that's always just kind of where you're going to start at when you go and are trying to graph some of these functions. Remember that sine starts at the origin and cosine starts at the point 0, 1. Okay? Alright. Here's another little bit of information for you. So we're going to talk about the amplitude. So amplitude is essentially how high the function goes or how low it goes. Amplitude affects the height and depth of the function. So the amplitude of just your regular sine function is at 1. So it goes up, its highest point is at 1, and its lowest point is at -1. It just repeats itself up to 1, down to -1, up to 1, down to -1. Just over and over and over again. Okay. So if I have a function, a sine function, and I'm trying to figure out what the amplitude is, then I look for this number in front of the sine function. So it's essentially the leading coefficient of your function. We'll call that A, and that A value is the amplitude. Okay. So look at this graph. So this is a sine function, and the amplitude here is 3. All that does is it's multiplying the height and the depth. So where this was at 1 before, when we have an amplitude of 3, the height of the function goes up to 3 now. And then it goes down to -3. Back up to 3, back down to -3. So if I was looking at just the graph of the function and it asked me what the amplitude was, then I can look and say, what's the highest point? Well, 3 is the highest point, so my amplitude has to be 3. Okay? So, find the amplitude for the function. If I just give you a function like this, and you're looking for the amplitude, you look for the leading number here, whatever number is being multiplied by everything else, and that's 3, so the amplitude is 3. Pretty easy, just look for that number. Okay, and then when you go to graph it, again, if it was a sine function, it would just start here, and you would go up to 3, down to -3. If you're wondering about how far the period goes, each essentially hump of this goes from 0 to pi, and then from pi to 2 pi, and that's basically how we're graphing those functions. So if you went through and you just put a point at the origin, and then at pi, and then at 2 pi, you know the amplitude is at 3, so you're putting a point up there and a point down here. You could get a pretty good picture of your graph just by drawing an up and down curve, just like that, to be able to graph that part of it. Okay? Alright. Let's look at something else. Let's look at the period. So I've kind of talked about period a little bit. The period of a trig function is how long the wave is before it repeats. So that's basically what I've already told you. So like sine starts at 0, and it goes up to 1, down to pi at 0, and then back down to -1, and back up to 2 pi at 0. So this thing right here, just this curve, just to this point from 0 to 2 pi, is the period of a sine function. As long as there's no transformations or anything put on it, the period is always a multiplier of 2 pi, or a distance of 2 pi. Okay? So, if I have a function of sine or cosine, all these rules apply both ways, the sine and the cosine function, and I'm looking for the period. I know that A is the amplitude, we just talked about that, and B is the multiplier, the number that's multiplied by x, that you will use to find the period. And there's a little formula that you can use for sine and cosine. You can use the formula that the period is equal to 2 pi over b, and that b is just this value right here. So, for this little example here, when we're graphing it, all we do is we would say 2 pi, here's our b value right there, is 2, divided by 2. Well, that means my period is pi. So starting at 0 for the sine function, I'm going to go up, down, and back up for my whole curve, and that's all going to happen between 0 and pi, instead of up here, this one was from 0 to 2 pi. So you could see that the period got shorter, and is just right there from 0 to pi. Okay. So again, on this one, if I wanted to find the amplitude like we just found it, and I know this one didn't ask for it, but I'm going to put it on there anyway, it was 3, and my period is just like this example here. There's my b value right there, 2 pi over 2, which means my period is pi again. Okay. So at this point, if I was going to draw a little graph of this, just to start out, remember I said that sine always starts at the origin. My halfway point is going to be pi over 2 on this one, because my full period is at pi, so that would be my ending point. Here's my middle point here, and my amplitude is 3, 1, 2, 3, and down 3, 1, 2, 3. So about halfway between 0 and pi over 2, I'm going to make a point up here, and about halfway between pi over 2 and pi, I'm going to make a point down here, and it goes up, down, and back up again. And there's my function. And if I wanted to draw another one, it would be the same way. I'd be going up to 2 pi now, halfway between that, is 3 pi over 2. I'll go up again to 3, about halfway between this, and about halfway between 3 pi over 2 and 2 pi would be my other. Here's the second part of my curve. And it would just continue on and on and on again, going up by pi each time. It doesn't have to be perfect, just a sketch. Okay? Alright, let's look at something else here. Let's talk about a phase shift. So a phase shift is similar to a horizontal shift and the other functions that you have worked with. So like these horizontal shifts of a function, let's just use the line, remember, was in the parentheses, and it would be like x minus 1, and then we would have something out here, plus 1, that would be the up and down. Well, this piece here would shift to the left or to the right, depending upon the sign. This one was negative, so it would shift to the right. Hopefully you guys remember that. It's the same looking kind of thing on sine and cosine functions. It's just more stuff added in because we've got the amplitude, the period, and then this is the value that we're going to use to find the phase shift. So it's just like that -1 there, except it's minus c here. It's just some value. Okay. Same way with cosine. A is the amplitude, b is the multiplier that you use to find the period, and c is the phase shift. There's another little formula here that you use. Okay. And that is that the phase shift is equal to whatever the c value is divided by the period. We essentially had to factor out the period in order to find our phase shift. Okay. Alright, so let's look at this. Again, it says what's our amplitude. We already know that. We did that previously. Amplitude is 3. The period, I know, because we just did that, is pi. Remember, we took 2 pi and divided by 2 and got pi. Now the phase shift, we're going to have to do we need to take our c value, divide by 2. Remember here, because we're adding 1, our c value is going to be -1. So our phase shift is -1 over 2. Okay. So that's what our phase shift is. Here's another little example. Okay. This is sine of t minus pi over 3. And what it does is this is our original function, just like this. I don't know if you can see it very easily or not, but here's a light outline of the parent function of sine. And all it did was you could see that the solid line is this function. It shifted it over pi over 3. So it went to the right pi over 3. This one that we did over here would move it to the left 1/2. Okay. Alright. So again, if I was going to make a quick sketch of this, 1, 2, 3, 1, 2, 3. I know my initial point is at 0 for my parent function. I'm going to just shift it over a little bit. So let's mark pi up here. So here's pi. Here's 3, -3 rather. Here's -2. Here's -1. Here's 1, 2, 3, and there's pi. Halfway between here and here. would be pi over 2, but I'm not going to worry about that right now. This one, because it's a number that's not with pi, is it's a little weird. But in any case, this 1/2 is going to be halfway between here and here, and so all of our points are going to be shifted over that much. So pi is going to be down around in here now. So I'm taking 1/2 off of it. And so we're going halfway between here and here, just somewhere around in here, going up to 3, right around in there, down here to -3, and here we go. And when you're sketching these graphs, all you really have to do is one period of it, because everybody knows that it's just going to repeat itself over and over again. So if I ask you to sketch a graph of something, just sketch me one period. Okay? Alright. So that's a phase shift. It's just moving it left or right. Last thing is a vertical shift. This is just like every other function that you've ever done. Vertical shifts moves it up and down. And it's just adding one more number on, so the amplitude, period, phase shift, and our vertical shift. Okay, and this is the same for sine and cosine. It doesn't matter. The main idea is the starting point for sine and cosine. Remember that sine starts at the origin for the curve and goes like this, and cosine starts at 1. Looks the same way, it's just shifted over and it has the same pattern. Okay. So here's sine of the function. Here's a transformation of that. It's got a vertical shift of 3. So it's moving it up 3. So every point, not like the amplitude that just changes and stretches the thing out, changes the height and the depth. It just takes that point at the origin and moves it up 3 units, and that's our starting point now. Sometimes it might be easier if you draw just a little line here to help you think about it and pretend like that's the x-axis, and then just draw your function again. Okay? So on this one, it asks for the amplitude, period, phase shift, and the vertical shift on this. So again, we know the amplitude is 3. We know the period is pi. We know the phase shift is -1/2. And we know that our vertical shift is -4. Okay. So putting all those things together is just like this one here, except all these points are going to be shifted down 4 units. I'm not going to go through and draw that for you. I think you can figure out that we just 1, 2, 3, 4, and that would be our starting point for that function, and it would look similar. Our ending point and our midpoint are all going to be about the same. Okay? So that's all there really is to do in this. We know how to find the amplitude, the period, the phase shift, and the vertical shift. You find all that stuff, you could sketch any one of these sine or cosine functions. Alrighty, I know this video was kind of long, but it's the last one in this unit. So get some practice done on this stuff, do your homework, all that good stuff, and I'll talk to you later. Have a good day.